Good morning, everyone. Today, I want to talk to you about a feature that was recently released in SQL Server 2022 and Azure SQL. It's called SQL Ledger, and the goal of SQL Ledger is to maintain the trustability, transparency, and integrity of the data in your database. So I will take all the questions in the end. I will leave at least 10 minutes to it, so feel comfortable to ask via the app or in the end of the session. So a little bit about me. I worked with data for around 6 years, and I've started as a data analyst, mainly working with Power BI. And then 2 years ago, I started migrating to a data engineering line. And I'm a big fan of blockchain, cryptocurrencies. And when I saw that Microsoft was releasing SQL Ledger that uses blockchain, it caught my attention. And I decided to bring you this to talk about this feature, because I feel that as data engineers and as we work most of the time with data, we take care of data, we transform data, we also need to pay attention and know how we can guarantee that the data that we are working with is trustable to everyone. So one important term that it will be important for the long of the session is data tampering. And data tampering is defined as any unauthorized data modification. It can be internally by a database administrator. It can be by a common operator that has privileged access to your database, or it can be made by an external attacker that can have access to the database files and made some unauthorized modification, and making sure that it doesn't leave any track of these transactions. And it can be bad for any organization, because nowadays we rely on the quality of our data. And if we can't guarantee to every part of our organization, our partners, our clients, that the data that we work with, it's true, it's clean, it's transparent, it's integrity, we are in a very bad situation. So SQL Ledger has the goal to take care of these data tamperings. A little bit of context. So why the SQL Ledger appeared? Data integrity can really be a challenge, because we are using to keep the integrity of your data. You mostly rely on external sources, external tools, and it can be most of the time costly, hard to manage. And as we talk about data quality, it's a very sensitive subject nowadays. And we need to make sure that the data that we take care is of good quality, and our clients trust in it. And also, attackers, threats, they are everywhere, and we need to make sure that even if someone can have access to that data, we need to guarantee that we can revert those damages. And of course, nowadays, more and more organizations start moving their data to the cloud, and also those cloud providers need to be trustable. Most organizations just use and rely on other organizations to monitor their data, evaluate their data, evaluate transactions, and they trust that if something happens, they will catch it, they will monitor it, and they will warn them to those unauthorized modifications. And that can be another difficulty, because it's very hard to any outside organization or any outside tool to guarantee that I can simulate every vulnerability of my data in any kind of scenario. So, and this is where the blockchain comes in. Blockchain is around for many years now, and basically it can be a solution to take care of these data integrity problems. So for the ones that are not very used to blockchain term, think about this in a simple way. Think about it as multiple blocks that work in a network linked to each other, where I store my information across over that blocks. So my information is not only stored in one place; it's stored around many places. This is a very simple way to explain blockchain. We just don't have time to it, but that way we can guarantee that our data is not simple accessed, because it is distributed in this decentralized architecture where I don't have the data in one single place. It has numerous algorithms to ensure the data encryption and several transactions that run to ensure the integrity of the data and that the data was not be tampered. So blockchain can really be a solution. The problem is we rely again in build external tools using blockchain, and most of the database management systems are not prepared to directly communicate with these technologies yet. And it demonstrated again, very hard to manage, very costly, and and this problem raised another problem of the costs. And this is where SQL Ledger come in. So basically, this is a new technology. It's very recent. It's on preview until the end of the last year, and it was released from the SQL Server 2022 and the Azure SQL. And the goal is to keep the integrity of your data. And this is not. This is very related to data security, but the kind of data security that Ledger protects, it's not from attackers, it's not from possible injections in your data, but it's to be able to verify your data and tells if the data is true for every part of the business. So it has two levels of security. One, detect and see any data unauthorized movements, and in the end, check if your data was tampered via unauthorized access, like database file modification, where you don't leave any transaction to be validated. So this is a scheme for the SQL Ledger architecture. And SQL Ledger introduces a new kind of tables that are called the ledger tables. And the ledger tables can be of two kinds. One of them, the append-only tables, where you can only insert new data in those tables. You can't update or delete information. And the most used ones, the updatable ledger tables, when you can do any DML operation in it, insert, delete, updates. And it works major as it has the same architecture as a regular SQL table. The only difference is when you say that, when you create this kind of table and you say that this is going to be a ledger table, you create more ledger objects. As you can see, when you create an updatable ledger table, you create an history table aside that is related to this table. And this history table will keep all the historical records of the main table. So if you do an update, the older record is kept in the history table. If you do a delete, the deleted record is kept in the history table too. This way, you can guarantee that you store every alteration, every modification that someone have made to your database, and it also records all the transaction IDs, so you can go after the transaction ID to know who did the modification and when it did. These tables are also protected against the drops, truncates, deletes. So you cannot delete data from these tables. If you drop these tables, they will be stored in the database. I will show you in a few minutes. So you store this data in the main table, you store the historical data, and it's kept forever in this database. Also, when you create the ledger table, a ledger view is also created related to this ledger table. And basically, this ledger view will show you every transaction that have occurred in that ledger table. So 3 objects here. You create a ledger table, you create a history table, and you create a ledger view. So this is very simple so far. The new thing here that you can see in the bottom, it's called database ledger. So database ledger is basically transaction blocks that are listening every transaction that is occurring. They listen for around 30 seconds. In a 30-second window, they listen all the transaction. They store the transaction. They encrypt it, and you store that information in your database. Every 30 seconds, a new block is generated. It's linked to the other block, and it keeps listening every transaction that is made to the ledger objects. And this way, you create a transaction of transaction chain, and you build your blockchain inside your own SQL database. So the big difference here for not relying in blockchain technology. You are using blockchain technology, but you are using it inside SQL Server or Azure. That's a big difference, and it makes it really low cost and really fast. So this engine is always working, and these transaction blocks are being stored in your database, but also you are keeping those transaction blocks in a trusted storage that it can be a storage account or Azure SQL confidential ledger that is a new kind of storage that I will explain to. But this trusted storage will be kept. It can be kept in the cloud in Azure, or if you are using on-prem, you can create your own trusted storage with your own access policy, whatever you want. But you have to guarantee, for the purpose of SQL Ledger, that this trusted storage it has the certain access policies, so no one can access and make modifications to the information that I've stored about my transactions. So every time a transaction occurs in my ledger table, I store it encryptedly in a transaction block, and that transaction block is also stored in the trusted storage. So why do I need this trusted storage? This comes the second level of security of SQL Ledger, the ledger verification. So if someone has access, I'm not talking about normal updates where you can keep track of transaction history, but if we are talking about someone that have access to database files directly, and it can do the modifications that they want without leaving any trace to be followed, there's a problem. How can I detect it? So while I'm storing in my trusted storage every transaction that have occurred, when I run my ledger verification, I compare every transaction that I have in my trusted storage, that is my source of truth, and I compare it to the data in my database. So if everything is okay, I will compare every transaction, all the data, and they will match, and the verification will be successful. However, if someone did any modification and no transaction was recorded in my trusted storage, my verification will fail, and I will detect that someone has tampered my data. So I will show you this in practice. I will show you how you can configure your trusted storage, how can you create and manage your ledger objects. So here in the portal, you can configure your digest storage, your trusted storage, in two ways. First things first, you can create already. If you are running a SQL Server 2022 or in Azure SQL database, you can already create your ledger objects. But to run this verification that I've talked about, you need to configure, and this is a step that you need to do. It's not already on. You need to create digest storage with a certain level of access policies, and you need to link it to your database, to the database where you want to create your ledger objects and start to store the transactions. So there are two ways you can do it. The first one is when you're creating a new database. You came here to the Security tab, and you have an option called Ledger. You click Configure Ledger, and here you have two options. The first option relied on Ledger database. It asks you if you want to enable the ledger for all future tables in the database. So if you want to create a new database and you want to make it all full ledger object, all full ledger tables, you can enable this option. It's not very useful to do this in every table in your organization, but if you want to, you can. Important note here, you can only activate this option if you are creating a new database, because you cannot do this when you are applying a ledger to an already existed database, because this is the only purpose of this option is to create only ledger database, okay? So the second option that we are talking about is the where you enable automatic digest storage. So you enabling this option, you are selecting a storage where you are storing those transaction blocks and keeping them safe and to be validated later. So you can have two kinds of storage here. You have a common Azure storage, and as you can see, you need to configure some retention policies, access policies. You can do it here. If you follow this link, you have a more deeply guide for you to do it and guarantee that the storage is safe. But when you are creating a new storage account, you have an option that you must activate here. You come here to data protection, all on the bottom, and you have this option, enable version level immutability support. Basically, during a time period, you are setting a retention policies where only a certain level of users can access this information. Because the goal is not to everyone have access to the digest and the information about the blocks. The purpose of this information is to be stored and to be used to validate my database. So you can activate this option and create your storage account and link it to your database. Then you have a second kind of storage, and this is a storage that was also released alongside SQL Ledger that is called Azure Confidential Ledger. It has a whole level of protection, of course, another level of costs, and it is encrypted in with all the data at rest. While it is transacted, it stores the information using the blockchain architecture. So, and you can't have access to the data in this database, so you don't need to configure anything to set up this storage. And of course, if you select it, you need to create a new ledger storage. It's very easy. You just need to give it a name, and you are ready to go. The other way you can enable digest storage is you have already a database and you want to start applying Ledger. So I've already a database here. You come all the bottom in this option pane. In the security tab, you have the Ledger option again, and you have the same two options. As you can see, I cannot enable the first option. As I said, this is not a Ledger database, but you can as I showed you, you can configure digest storage. So in this database, I choose the Azure Confidential Ledger to run this demo. So I have my digest storage linked to my database, so I'm going to start and build my Ledger objects. So here in my management studio, I'm already connected to my database. So the first thing you need to do is create a ledger table, and it's very easy to create it. As you can see, it has the same structure as a SQL regular table with two options. The first one, the system versioning, you have to enable this. This option is what will take care of the history tables, that management. And this is a management that already exists in SQL Server, and you can use it here to manage the history records. And then you can you activate the ledger option too. That's it. You run this and you create your first ledger table. In this case, by default, it creates an updatable ledger table. So if I came here to my tables, I created a table bank account with account number, account type, a balance, and a user ID. So we will take this scenario of a bank account. So as you can see, I have my table here. It has the updatable ledger type. If I expand it, you can see that I have a ledger history for this table. So once I create the ledger table, I already have this object, ledger history, and it has the same schema as my main table, okay? And if I came here to my views, I have a bank account view too. So we will start to add some data to start working with these tables. I will run this. We have some data here. Let's take a look. So I will select the data in my bank account for user 1. So I have a balance of 1,000. Okay, very simple here. I don't have any register in my history table yet, but I will do an update right now, and I will update my bank account for user ID equals 1, and I will set the balance to 1,000. So if I'll take a look again to the data, the update of occur. Okay, so far, the new balance is here. If I take a look at the history table, there's a new register with the old balance, okay, and the information about the transactions that are associated with this operation. And if I look at the ledger view, I have all the operations, all the transactions that have occurred in my ledger table. Okay, so far. So we have the inserts to register that have been inserted in the beginning, and we have the new modification, the update that the ledger stores as a delete and the update. So ledger it deletes the old record and inserts the new record. So this is the update that we have just done. And again, it has the information about the ledger transaction and some sequence transaction number and the information about the operation type of transaction. So if this data can be, of course, monitored, if someone that was not supposed to modify the data, we can know that modification have occurred, and this data is stored as history. So, of course, we can think, okay, we can delete those records. No. So all the data that we have in ledger objects can be deleted. If we try, for example, to delete the record that we have in the ledger history, it will throw me an error that ledger history table cannot be updated. Also, if we try to truncate the data in my table, you can too. So it's a not supported operation for system versions already, but you cannot truncate the data in your main table. You can drop columns. You can change the schema, yes. If you add new columns to your table, as long as they are null by default, you can. Okay, so as long as you can't affect the history of the other records, you can change the schema. You can also drop columns to your tables. I will drop the account time from bank account table, but if I take a look at the columns of my bank account, that column was not deleted. It has basically changed the name of that column. It's not. It still can be used with this name, but it's not a very friendly name. But you can't. You can see it as a limitation, but I see it as a feature. But because you need to ensure that every data even if it's dropped, even if it's deleted, it still stays here to be validated later. So as you can see, the column that we just dropped is still here, and it will stay here as with this name. We can also drop our table, and the same thing will happen. If we refresh it, as you can see, bank account is a dropped ledger table now. So when you do a drop any object, drop any column, the only thing that happens is it renames the name of your object, and you still keep the object for you. It not drop it definitely. So there are also some sys tables around the ledger. So if you want to take a deeper look in SQL Ledger and knows and sees how the transaction works, how the block of transactions are being stored, you can check these tables. So the first one is the database ledger transactions, where you can see every transaction that have occurred across your ledger objects. So you have the information about the transaction ID. You know in which block of transactions it has been stored, when it was executed, who executed the transaction, and you have encrypted all the information about the state of the table that table has in the point where the transaction have occurred. So you have all that history record encrypted in this table of transactions. You can also take a look at all the ledger blocks that you already have. So the database ledger blocks is basically one row per block. You have encrypted all the transactions that have occurred and that have been stored in that block. You have the block size that tells you how many transactions have been stored there. And you have also the previous block hash that is an encrypted key that is used to link each block to the previous one, building this blockchain like inside SQL. You also have another tables that you can see. You have the ledger table history, where you can see all the history of the tables, if someone table was deleted, if someone which tables were created, okay, with which every transaction ID operation. You can also do the same thing to the columns. Okay, so you have the information about every object and what happened to that object. So the last one, database ledger digest locations. It will tell you where and which digest location, what is your trusted storage and where it is being stored. So if I select it, it will tell me the path where I have my confidential ledger storage, and this path will be used during the verification process. So this brings us to the last step of Ledger, that is the ledger verification. So far, if someone did a normal update or delete to your data, you can monitor that modifications and act as well. But if someone, as I said, have access directly to the database files and do any unauthorized operation without leaving any trace, you can run the ledger verification to compare every transaction that you have stored in the trusted storage and to compare it to the data that you have in your database. So this is a T-SQL script that is generated in your Azure portal. So if you came back here, you can see in the top this verify database option. If you select it, it will automatically generate for you a T-SQL script that you can copy and paste it. So it's exactly the same that I have here. So basically what this does, I will use my digest locations as a parameter, and I will select all the digest locations that I have available, I can only have one ledger location associated to my database, but if I have all the locations that I've already used in the past, those locations still need to be used for validating all the records. So I will use as a parameter these locations, and it will execute this stored procedure that will do exactly what I've said. So it read all the transactions that I have in the trusted storage, compare it to the database data, and if everything matches, so the verification is successful. However, if there's something different, the ledger verification will fail and will alert us that the data was tampered. So if we run this script, it will, by default, it will tell me which digest locations were validated. In this case, only one. What was the last verified block of transactions that was validated, and what was the result? In this case, it was a successful result. So, by curiosity, if I have a storage account here that I've used before for SQL to store my digests, and I didn't set any policies to it, so I can access the files. So this is the file, the ledger storage, a normal storage account, and I will just show you how this data is stored in this file. Okay. Okay, let's see. You will see that it is stored in a very simple way. So as you can see, it's stored like this: database name, what is the block ID, transaction encrypted, the last transaction time, the last commit, the last digest time, and you have this for every block that you are storing in this digest storage. Okay. So this is storage like this. In normal cases, you can't have access to it, but I didn't set any policies in this storage, so just for demo purposes. Okay, so let's take back here. So, of course, when we talk about cloud environments, it's very hard to someone have access directly to the database files and do some modifications. It's really hard, but it can happen. It's not impossible. So when this happens, the thing you need to do, you have to check your, basically you have to check your backup storage. You have to validate and run the verification for each of your backups to see in what point in time that backup was valid, it was successfully verified. You restore your backup to that point, and if you have made some transactions before the data was tampered, you need to again redo those transactions in your database, so to make sure that the data that you still have in your database is the same of the transactions that are stored in the trusted storage. So in the future, you have a successful validation and verification. So as we have talked about, this is the main feature of SQL Ledger. We are talking about distribution. So all the information of my database, all my data is being stored across multiple blocks. And we are talking about a centralized architecture. But when we store all our transactions, we are keeping it in the centralized architecture, what we call the transaction blocks, that is stored in a blockchain architecture too, if we are using the confidential ledger. Of course, security, everything is encrypted when it's stored, when it's being transacted. And in terms of scalability, it can deal not only with lower volumes of data, as I showed you, but with large volumes as well. You have a great paper by Microsoft that goes deeply in this subject, and they show you some scenarios that they compare. For example, the performance on DML operations on ledger tables or in regular tables. And in this case, you see a slightly increase in time doing these operations in ledger tables, the three on the top. Just because when you do a ledger update, when you do a ledger delete or insert, you need to make sure you have all the background work where you need to store the information in your history table. You have to store your transactions in the blocks. You have to store those transaction blocks in the trusted storage. Of course, many of those processes are doing in parallel, but it takes just a slightly amount of time in these operations. As well, the ledger verification process. As you see, we are validating, I guess, 30 transactions, I believe. It was very, very quick. But if we are talking about millions of transactions, it will take some time. So, as you can see here, if we are talking about, for example, 40 millions of transactions, it will take around between 20 to 30 minutes to run this process. It's not a process that you run every time, every minute, but you probably would want to run it a few times a day, just especially if we are talking about a highly demand database with a lot of transactions every second. So this is something that you have to take in consideration. Also, Ledger has some limitations yet. So as I said, the drop objects, the truncate, you can't do that. It is considered a limitation. I don't consider it, but you have some more. So in-memory tables aren't supported. CDC aren't supported too. So your ledger tables can't work with full text indexes. It can be graph tables, file tables, and also it can have a row store non-cluster index when when they already have a cluster column store index. So some limitations. There are a few more, not pretty relevant, but you can check that in that link. So for the future, this is a very recent technology. Of course, we are not talking about blockchain. Blockchain is around for many years already. So, but I see that this technology to be adopted by organizations that want to that already uses some Microsoft services, Azure services, and want to add an additional level of security to that data at a very nice cost, and to guarantee the integrity of those data. So I see it in that way. It's very recent. Many organizations are already using it since it was released in preview. Like Lenovo, we are using the SQL Ledger to keep the data safe and trustable of all the supply chain of their computers. You see some health institutions are already using it, mainly in the COVID vaccination, when they wanted to make sure that all the information stored about the vaccination of every person is being stored, and it in a way keeping that information trustable, and that nobody wants to do some data tampering to it. And there are of course, this is an important stage, and as we talk more and more about blockchain, this feature comes in a great time. It needs still to be. It's a very simple technology. There's no much that can be improved, but because the purpose of this technology is to be simple and to be used by everyone. As you saw, every step that I made it was very simple, and in that way I can guarantee that my data it's trustable to everyone that works with me. Of course, more use cases. Blockchain is already being used in a lot of scenarios. I believe each of you have something in mind. So, but probably the most important for the future will be in financial services, to improve the security and reliability of the systems, to ensure more trustability for the clients, in healthcare, as I said, to keep safe all the information about the patients, all confidential information safe about disease, internal processes, and also in supply chain to ensure the reliability and the transparency of all the steps in a blockchain for a product, for example, to guarantee that, for example, if something happens to a product during the manufacturing in a fabric, someone in the organization cannot go to the data, change the data in favor of the organization. So there are a lot of scenarios where this can be applied. So again, those are my contacts: LinkedIn. You can send me a message. Gmail can send me an email too with any questions. I also use Medio to publish mainly SQL articles and data engineering articles every week. You can check it too. So feedback is much appreciated. Thank you very much. If you have any question, feel free to ask.
Ledger table, and then you also mentioned there's another option, which is the append only. So are they, when you create the append only, would it also create a history table?
No, because you don't. Oh, so the question was, if when you create an updatable ledger table, you create an history table and a ledger view. When you create an append only table, what happens? So you don't need an history table in this case. You just, when you're creating the append only table, you just turn on the option of append only when you are setting those options, and you are only creating the ledger view to check the transactions that have occurred in the ledger table.
So it doesn't have history table?
No, it doesn't.
Does it still have the view?
Yeah, the view, yes. So you can control and have access to the ledger transactions. Thank you. Gentlemen.
Can you apply this to an existing table?
Oh yeah. Those is also considered a limitation. To apply this imagine if you have already an environment where you are working with your tables and you want to start to those tables being ledger. So the process that you need to do, you need to create a ledger table with the same schema of your tables, and you need to migrate those information to the new ledger tables.
Two questions here. Does the table affect the transaction log size at all, or when you store all this ledger tables, does it affect your transaction log size and how you deal with backups and things?
Okay, it affects the log size. Of course, it will affect the log size as much as you storing normal logs for every kind of transaction that you have already did before. So the thing with backups and what is recommended is do as many backups as you can for you to be able, when you are restoring the information, restoring your database. Imagine if you are tampered and want to restore it to a point in time where your data is valid. If you do more backups, you do more specific, you can go back to a specific point in time and to guarantee that you don't lose as many transactions as it could be.
And then, sorry, the second question was, you showed us how the name of the column changes when you do a drop. Does that change in both the ledger table and the history, or does the table
it changes in every object? So it changes in a ledger table, ledger and ledger history table. Yes. Oh, okay. Another question.
Is there an actual way to clean up or remove the ledger table once you enable it?
So the question is any way you can remove the data from your ledger table, the old data? Currently, no. That you can't delete any data, and you can't remove definitely all the information, even if you are dropping it, you are still keeping that information and you cannot remove it. And I believe, I've talked to some people, and some people see this as a limitation. But if you want to keep the integrity of your information, you need to make sure that that data doesn't disappear. So you don't. You have to be able to validate all the history. So in that way, what was the purpose of this technology? Thank you. Another question there? I didn't text that. I did, the question is if I can rename ledger tables. I believe yes, okay? And if you rename the ledger tables, the ledger view will be renamed and the ledger history will be renamed too. Another question?
How often do you, I mean, are you supposed to, once the verification check, you know, just now you show us how to make sure that the trusted storage has the same, I don't know, stem as the database, the data in the database. How often do you need to run it? Or
I see.
supposed to run it regularly?
No, if you are dealing with large volume of data, it will take some time, as you saw. So the question is, how many times do you need to run these verifications to validate your information? So you can run it as many as you want, because if you are dealing with highly transactional environments of data, and which every second you have thousands of transactions being made, and if you want to make sure that nothing happens in between, you need to run as many times as you can between of course the time that the verification takes. Thank you. Another question back there?
Yes, if someone has access to my database file, also to the digest storage, then I guess potentially they can modify data in both places in a way that the verification process will succeed. Is that correct?
Yeah, that's a very good question. So if someone has access to the digest location storage and have access to the database files, so they made the modifications in both sides, what happens? So I'm going to be honest with you, I don't know the answer to your question, but usually the first step that you need to do is making sure, at least in your digest storage, that you use the right SS policies to it. The goal here is, as I said, is not to take a look at the transaction blocks that I've stored. It's really I just store this data. Nobody needs to look at this data. Nobody needs to access this data. That's the first rule here. Okay, thank you. Okay, I think we are done. Thank you very much for coming.